Hello, thanks for returning. We are going to be going over Chapter 10, Length, Area, and Volume. Let me go ahead and share my screen with you so we can get started on this lesson. All right, here we go. Let me move this up out of the way so y'all can see the slides a little bit easier. Okay, so again, like I said, we're going over Chapter 10, Length, Area, and Volume. Now, our first problem, we're going to be doing conversions. We are going to, let me get my pointer out. We're going to be converting these into different, seeing how many jills will fit into pints and stuff like that. So what we're going to start with is we want to know how many mouthfuls are in a jill. Now we see over here that there is 1 jigger in 2 mouthfuls. So we know that 2 mouthfuls equals 1 jigger, but we're wanting to know how many jills or how many mouthfuls are in a jill. So here's our conversion. We're going to be using the doubling system. So basically what that means is we have 2 mouthfuls equals 1 jigger, and 2 jiggers equal 1 jack, and 2 jack equals 1 jill. So we're basically just doubling. So when we want to figure out the mouthfuls to jill, we see that we can work our way up from mouthfuls to jiggers to jacks to jills. So we have 4 mouthfuls, which is equal to 2 jiggers, which is equal to 1 jack. So that makes 8 mouthfuls equal to 2 jacks, which is what is equal to 1 jill. So we have 8 mouthfuls equals 1 jill. Now next we want to know how many mouthfuls are in a cup. Now we already know that 8 mouthfuls are in 1 jill, and there are 2 jills into 1 cup. So we're going to double it. So we have 8 mouthfuls times 2, that makes 16 mouthfuls, which is 2 jills, and there's 2 jills in a cup, so we have 16 mouthfuls in 1 cup. Now how many mouthfuls are in a pint? Now if we look over here, we see right here that there are 2 cups in 1 pint. So just like we did with the mouthfuls in the cup, we're going to be doubling everything. So there's 16 mouthfuls in 1 cup and 2 cups in 1 pint. So we're going to double it, and it's going to be 32 mouthfuls for 2 cups, which makes 32 mouthfuls for 1 pint. Now here is just a picture representation of how many mouthfuls are in a jill, cup, and pint. And I did chocolate milk because that is my favorite drink. I love me some chocolate milk. So we're going to start with jill. And we know that there are 8 mouthfuls. So 8 mouthfuls of chocolate milk equals 1 jill. Now we move on to cups. And we have 16 mouthfuls because remember we are doubling. 8, 16 mouthfuls of chocolate milk makes 1 cup. And we're going to continue on, and 32 mouthfuls of chocolate milks make 1 pint. So 8, 16, and 32. We're just doubling it as we go. Now let's fill up a pail. What we want to know is how many gallons, bottles, quarts, pints, jacks, jills, cups will fit in and mouthfuls will fit in this pail. Will it overflow? Will it just fill it up completely? Or will there be more room to spare? So what we're going to start with is we know that 1 pail equals 512 mouthfuls based off the conversion sheet that we used on the previous slides. So 2 gallons is what is equal to 1 pail as well. So 1 gallon will be half of a pail, which is 256 mouthfuls. Because we don't want to use 2 gallons, that'll fill up the whole pail. We just want to know 1 gallon, 1 bottle. So 1 gallon takes up half of our pail. Now we move on to bottles. And there are 2 bottles in 1 gallon, and 1 bottle is 128 mouthfuls. So that takes up 1/4 of the other half that we have. I apologize, half of the other half. So 1/4 of the entire pail itself. And now 1 quart is half of a bottle, which is 64 mouthfuls. So over here, we will fill up a quart. Now 1 pint is half of a quart. So we take half of this other quart and split it in half. And that is where our pint goes. It is 32 mouthfuls. 1 cup is half of a pint, as shown on our previous, on our first slide when we were going over how many mouthfuls were in a pint. So there are 16 mouthfuls in 1 cup, and so that is half of our pint. And 1 Jill is 8 mouthfuls, and that is half of a cup. Now 1 Jack is 4 mouthfuls, which is half of a Jill, and so that will take up our other half. And 1 Jigger is 2 mouthfuls, which is half of a Jack, and it will fill up half of our other half, half of our other Jack. And then right over here, 1 Jigger is equal to 2 mouthfuls right here, as we see. So we're going to split this other Jigger in half, and it's going to be 1 mouthful. And now we see that we have an extra area, so that shows that our pail is not overflowing and it's not equal. So we want to know how much we have left. So we are going to take all of these numbers and subtract them from 512. And that gives us 1 mouthful left in the pail. Now we move on to area and perimeter. Here we have a triangle right here, and it's not a right triangles, it's an isosceles triangle. And we're wanting to know the area and the perimeter. So we're going to start with the area. Now the area of a triangle is 1/2 base times height. Our base in this triangle is 82.3. The base is just any bottom part of the right side of the triangle. And now this one is not a right triangle, but we are going to make one to get the height. You're going to start at the highest point and draw a straight line straight to the base where it makes a right angle, and that will be right here where our height is. So our height is 41 meters, which is already given to us. So we are going to plug these in, and it's going to be 1/2 times 82.3 times 41, and it comes out to 1,687.15 meters squared, because area is always your measurement squared. And then we're going to move on to perimeter. Now perimeter is a little bit easier because it's just basically adding all of our sides together. It could be on a triangle, it could be on a square, it can be on a 9-sided figure. You just take all the sides and add them together. So it's A plus B plus C for this triangle. So it's going to be 48 plus 69 plus 82.3 all added up right here, which equals 199.3 meters. Now we're just keeping the same measurement in the back. We're not squaring it because it's not area. It is not cubed because it's not volume. It's just all the sides added together, basically adding. If we laid this out into a flat line, unfolded this triangle into a straight line, how long would that line be? Now we're going to work on this triangle. Now you see this one is already a right triangle, so we don't need to find the highest point and bring it to the base to find the height to this triangle. So again, the area is 1/2 base times height, with our base being 88.8 inches and our height being 37 inches. And when we plug that in, we get the area of 1,642.8 inches squared. Again, our area is in squared measurements. Now perimeter, again, we're just adding all the sides together, which comes out to 222 inches. Now this one is going to be a little bit different. We don't have a right triangle, and when we bring it down from our highest point over, it doesn't necessarily make a right triangle either. We're going to make our right triangle, we're going to find the right side a little bit differently. So area, again, 1/2 base times height, B equaling the base, H equaling the height. Our base is 6.2 centimeters times 2.6 centimeters. Now that 2.6, this side right here is not part of the triangle, but it is our height. So we're gonna, the way we got this height is we drew this line out from this point all the way over, and then we started at the, from this point straight down, making a right angle. And that measurement right there is our height, not this one right here. Now this is the measurement of this side. We'll use that when we get to the perimeter. So when we plug these two into our equation, we get an area of 8.06 centimeters squared. And to find the perimeter, again, we just add all of the sides together. It'd be 3.1 plus 6.2 plus 8.5 centimeters, which makes 17.8 centimeters. Now we want to find the area of all of these shapes. How are we going to do that? We see we have a big square, a tiny, or a big circle, a tiny circle, and then a square in between. How are we going to find the area? Now we are given the units for the square, which is 10 units on each side. So to find the area of a square, it's just the sides squared. So area equals 10 squared. So our area of our square is 100. Now we want to find the area of the small circle. And the area of a circle is pi r squared. To find the radius, we don't have any numbers given to us for the radius, but what we do know is that the sides of each square, of this square, each side of this square is 10 units. And we see that our circle touches on each side right at the center. So we're going to know that our diameter is 10 units long. From one side of the circle to the other is 10 units long. And for the radius, it's just simply cutting the diameter in half, making it 5 units. So we're going to plug the radius into the circle. So we have the area of a circle equals pi 5 squared, which makes the area of the circle 78.5 units squared. Now we want to find the area of this bigger circle. Again, we have the sides to this square that are 10 units, and our area of our circle is pi r squared. But you see that this square doesn't go from the center of each side of the circle. It's kind of just touching in 4 different spots on the circle. It's not really going to the center here or here or here or here. So we don't know the true diameter of this circle, but there is a way we can find out. So we see if we turn our circle in our square and we go from this diagonal to this diagonal, it goes from one side to the other, and that will give us the diameter. But how do we get that? So what we're going to do is we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. We are going to draw a line from the center of our square out, and then we are going to make our hypotenuse connect the corner of the square to the center of the square. And since we know that our sides are 10 units long, we know half of it is 5 units. So we already have this side, and we already have our radius right, or our side right here, which is 5 units, because it is half of this 10 unit side as well. So when we plug those in, we have 5 squared plus 5 squared equals c squared, which makes 25 plus 25, which makes 50 squared, which is our radius. Now we are going to plug that into our equation for the area of a circle. So it's going to be pi times 50 squared. And the area of the bigger circle is 7,853.98 units squared. Again, our finding area, it's always going to be units squared. Now, what is the area in between both the smaller circle and the bigger circle? Now, we know the area of the smaller circle is 78.5 units squared, and the area of the bigger circle is 7,853.98 units squared. So all we're going to do is subtract the smaller circle from the bigger circle, giving the region between our two circles the area of 7,775.52 units squared. Now, here we have three shapes in one. We have a cylinder, we have a sphere, and we have a cone. Now, what are the volumes of each of these? First, we're going to break it down, and we're going to just pull apart our shape to find out which one's best fits. We're going to start with our volume of our circular cone. Now, the volume of a cone is 1/3 base times height, and we're given the base area of pi r squared. We're given the value is base equals r and height is 2r. So we are going to plug these in. Volume equals 1/3 pi r squared times 2r, which makes the volume 2/3 pi r cubed. Now it's cubed because our surface area, or not our surface area, I apologize. Finding the volume, all volume is measured in units cubed. So now we're going to move on to our sphere, and we're given that our sphere's volume is 4/3 pi r cubed. So there's not really much math we need to do there. Now the volume of our cylinder, to find the volume of a cylinder, it's base times height and the base area of pi r squared. And so we're just going to again plug those in. Volume equals 1/3 pi r squared times 2r, because we are giving our base of r and our height of 2r. And then so our volume is 2/3 pi r cubed. Now we want to find the ratio of the three. We have our cone, we have our sphere, and we have our cylinder. And we want to know what is the correlation between these three. So what we're going to do is we're going to divide all of our shapes by all of our volumes of our shapes divided by the volume of the cone, because we want to know the correlation to the cone. So the volume of our cone is 2/3 pi r squared. When divided by itself, it comes out to 1. Now, when we do that with the volume of the sphere, remember our sphere with volume was 4/3 pi r cubed. And when we divide it, our pi r cubes are going to cancel out, our 3's are going to cancel out. And when 4 is divided by 2, it means it equals 2. So now the volume of our cylinder. Now you remember it was 2 pi r cubed that we got, but when we write it into a fraction to make it equivalent to this, make our denominators the same, we come out to 6/3 pi r cubed. This makes it easier just to break it down and divide it by each other. So again, our pi r cubes are going to cancel out, our 3's are going to cancel out, and 6 divided by 2 is 3. That makes our ratios between the shapes a 1 to 2 to 3 ratio. Now we want to find the area of a trapezoid. You see our figure over here with our given measurements. And we are going to start with the area of the base. This is the surface area that we're wanting, or not the surface area. We're wanting to find the area of the entire 3D shape. So our formula for an area of the base, which is just this part right here, right in here, we're not worrying about this side or this side, is 1/2 a plus b times h, with a equaling our top length, b equaling our bottom length, and h equaling our height. So over here, our A, our top length, we see is 26 right here, because if we turned this figure on its side, this would be our top, 17 would be our bottom, because you see that this right here is the same length as this one, so this would be 17 as well. And our height, you may want to assume it's this 4 centimeters, but this is not what we were wanting. We were wanting this 12 centimeters, because again, when we turn it sideways and stand it up on this side right here, we're not worried about this part or this part. We're just wanting to know this trapezoid right here. So our height is going to be 12 centimeters. So when we plug these numbers into our equation, we get the area of the base of 258 centimeters squared. Now, to get the perimeter, we again just adding all the sides together. 26 plus 12 plus 17. And it comes out to 70 centimeters squared. You know what, guys? I did my math wrong. When we add the perimeter, you're wanting to add this 15 centimeters as well. So it's going to be 70 for these three sides, plus we're going to add the extra 15 centimeters that I forgot on my slide. I apologize about that. So it's going to be 70 plus 15, and we are going to have 85. So when we plug it in, it's going to be 2B plus pH is our surface area formula. And so it's going to be 2 times 258 plus, remember this 70 is actually an 85 times 4. So let's see here. We're going to do 2 times 258 plus, remember 85 because I made a mistake and forgot to add that 15 into our parameter, times 4. And so on here I have our surface area as 796. And it is actually 852 centimeters squared. Again, I apologize. So that is our surface, how to find the surface area of our trapezoid prism. Now we want to find the area of the triangular prism. Now this area, the area of the base is 1/2 base times height. So our B being base, H being height. Our base is 8 meters and our height is 15, because you see right here, this is a right triangle. If we're looking at it from the top up here and looking straight down at this triangle, we see this is a right triangle, and our height is always the side coming up from the base of the right angle off of the base of a triangle. So when we plug that in, we're going to get the area of the base of this as 60 meters squared. In the perimeter, again, we're going to do 8 plus 15 plus 17. It's going to be 40 meters. When we add all three sides together, the base is 40 meters. And when we put that into our surface area equation, which is 2 times B plus pH, with B being base, P being perimeter, and H being height, we see up here we use the height of 15 because this length is the same as this one, and we were only looking at this triangle, but now we're looking at the height of the entire 3D triangular prism, and we see over here this is the height we're wanting. So we're going to do 2 times 60 because that is the area of the base, plus 40 times 7, which is the height, and that gives us the surface area of 400 centimeters squared. Now we want to find the surface area and volume of this figure right here. So our surface area is 4 pi r squared. And the cylinder surface area is 2 pi r h. So we are going to add those together to get the surface area of our figure. And 22 is being the length of this figure, and 4 is just the radius, which is half of this circle right here. See, this is the big circle, and we see that the height or the diameter from one side to the other is 8 feet. So half of it would be 4. So we would just want the 4 in our radius, which gives us the surface area of 754 feet. Now to find the volume of this sphere, it is 4/3 pi r cubed, and the cylinder volume is pi r squared times h. So our volume is pi r squared times h plus 4/3 pi r cubed. And we are going to add those together. And we're going to plug in again, 4 is our radius, 22 is our height, and 4/3 pi. Again, our radius is 4. And when we plug it all in and do our math, we got 1,442.3 feet cubed. And again, it's cubed because it is the volume. Here it is squared because it's just the area, pretty much any outside surface. All right. So here we want the surface area of this cone and cylinder. So the cylinder surface area equation is 2 pi r h, radius times height. Our cone surface area is pi r s. And our circle surface area is pi r squared. So we're going to add them all together to get the total surface area. And when we plug it in, we get pi times radius. This is the radius of our circle of the base of the cone, which is 2 meters is the radius. So pi 2 squared plus pi 2 6, which is this length of this side. Both sides are going to be equal. They're going to be 6 meters because it's just one big round cone, you know. So, and then we're going to add that with 2 pi, 2, and 10 being our height. So our surface area comes to 176 meters squared. Now, we want to find the volume. To make this a little bit easier, we pulled it apart. So we're going to find the volume of our cylinder and then the volume of our cone. To find the volume of the cylinder, our formula is pi r squared 8 times h, with r equaling 2, again, which is our radius, and h equaling our height, which is 10 meters. The cylinder volume is pi 2 squared times 10, which gives us the whole volume of 125.6 meters cubed. Again, volume is cubed, so that how much stuff I can put inside of this cylinder. The area inside the cylinder. Now we want to find the area of the cone, or I apologize, the volume of the cone. We're going to use the formula 1/3 base times height. And then we are going to use the Pythagorean theorem to find the height, because we have the base. Remember the base right here? We're able to figure out the base. So we want to figure out the height. We need this number right here. And we're going to use the Pythagorean theorem. We already have the hypotenuse, and one side, we're wanting to find out the other side. So we're kind of doing a reverse Pythagorean theorem. So we got one side, which is 2 squared, and then the hypotenuse, which is 6 squared. And when we square those, it's 4 and 36. So a squared plus 4 equals 36. Now I subtracted the 4 from the 36 to get a squared by itself. And then we are going to do the square root of 36 because we have a squared on this side. And the only way to get rid of this is to do the square root on both sides. Because just like when we are solving for a without the exponent, the best way to get a by itself is you do the opposite of what is being done on this side. So plus 4 is being done over here, so we're going to subtract 4 to this side. And whatever you do to this side, you're going to have to do the other side of the equal sign. So we're going to square root this sign because the opposite of the squared exponent is square root, which gives us a equals 6, the area equals 6. Or the height equals 6, I'm sorry. And then we're going to plug in the height, which is 6, and the base of 2 into our equation, which gives us the volume of 4 meters cubed. Now, the total volume of the entire figure together, what you're going to do is you're going to take 125.6 meters cubed and add 4 meters cubed, and that gives us a total of 129.6 meters cubed. And that is the end of our presentation for today. I look forward to going over our next unit with you guys. I hope to see you again soon.